Um, I welcome you all to today's lesson. My name is Michael Tawonga Kamanga, and in today's lesson, I'll take you through a brief history, a brief background on the periodic table. And by the end of this lesson, you should be able to describe the periodic table. Describe the periodic table. Uh, well, the periodic table, um, there were some early attempts on how to come up or to design the periodic table. So in those days, chemists, physicists, mathematicians, they all attempted to design the periodic table. So it all started in 1789 by Antonio Lavoisier, who is often called the father of modern chemistry. He managed to identify the three elements and he grouped them into categories. That is gases, metals, non-metals, and Fs. However, many of these elements were later found to be compounds. So this was like a drawback. Then in 1829, Johann Wolfgang observed that certain groups of three elements, that is the triads, had similar properties. And the atomic weight of the middle element was approximately the average of the other two. So his work laid the groundwork for future classification efforts. So him observed the triads, the three elements, and he observed that these triads had similar properties. So he paved way for more discoveries on the periodic table. And then in 1864, John Newlands uh, proposed the law of octaves, stating that when elements are arranged in order of increasing atomic weight, every eighth element has similar properties. So him again utilized the fact that some elements were showing similar properties. However, his ideas were initially uh, ridiculed because they only worked for lighter elements. So this idea left out all the heavier elements. So this was like the drawback for him as well. Now, this periodic table is one of the most important tools in chemistry because it gives the general idea, the general overview of elements. So providing a systematic way to organize and understand the elements, that is why its history is very, very fascinating. And uh, after some time, Dmitry Mendeleev, who was a Russian chemist, uh, and he's very famous as far as chemistry is concerned. He was credited with creating the first widely recognized periodic table. So he played a very crucial role in the discovery, in the designing of the periodic table. He was responsible for arranging the 63 known elements in order of increasing atomic weight and grouped them by similar chemical properties. So other scientists only discovered about similar properties, the similar properties amongst the elements. But on top of that, Mendeleev managed to discover elements that the elements were showing an increase in atomic weight. So because of that, he had to group them in order of increasing the atomic weight. So, however, he left gaps in his table, giving room to more elements, which by then they were not discovered, because he was bearing in mind that more elements will be discovered with time. So his predictions were remarkably accurate, and elements like gallium, germanium were discovered later, fitting perfectly into the table. As you can see, there's a picture there of Dmitry Mendeleev, the Russian chemist. So as you can see, people attempted uh, to design the periodic table. They were bringing in more ideas on the elements. So there was a breakthrough by Mendeleev, because he managed to arrange 63 elements, which was very, very crucial. So the elements which we are discussing now, the elements which we are using in chemistry now, they were arranged in a table known as a periodic table by Dmitry Mendeleev. Of course, some elements, people are still discovering these elements. That is why he thought it wise that, okay, what if I leave gaps in my table so that if people will be discovering the elements, they should be able to put them in the periodic table. So as you can see, this is quite interesting. So these people, they indeed contributed much. So the modern periodic table, the table which we use today, is organized by increasing atomic number with elements grouped into periods, the periods which are the rows of the table, and the groups which are the columns of the table. And these elements, those elements in the same group, they have similar chemical properties due to their valence electron configuration. So they will exhibit, they will always show similar chemical properties. Why? Because they will have their, the valence electron configuration is always the same. It is always the same. You may recall when I was talking about electron configuration. Remember that elements, the valence electron configuration, we are just referring to the electrons which are found in the outermost shell, in the last shell. So if elements have the same valence electron configuration, then they are grouped into the same group. Now, this periodic table, basically, it continues to evolve as new elements are discovered. As already alluded to, I said the elements are up to date. People are still discovering these elements. Even you can also discover elements with the proper guidance and with the proper knowledge of chemistry. I really wish that you should discover your own elements. Yes, you can. Yes, you can. So the periodic table remains a dynamic and central tool in the study of chemistry, reflecting the underlying underlying principles of atomic theory, and the relationships between elements. And of course, there are some refinements and modernization on the periodic table. So, like we have already seen that Dmitry Mendeleev was the one who revised the table. So he made several adjustments to his original table, correcting some of the atomic weights and refining the arrangement. Okay? So he was just fine-tuning the periodic table, which was there. So his work gained more acceptance as it continued to predict the properties of undiscovered elements. Then in 1913, there was Henry Moseley who discovered that the atomic number was more accurate way to organize the elements than atomic weight. Because Dmitry Mendeleev only arranged the 63 elements basing on their atomic weight. But Henley discovered that, okay, what if we, instead of using the atomic weight, what if we should be using the atomic number? So these were just some moderations. So this discovery led to the modern periodic law, which states that the properties of elements are a periodic function of their atomic numbers. They are a periodic function of their atomic numbers. And the periodic table organizes elements based on their atomic number, electron configuration, and recurring chemical properties. The chemical properties which are recurring in nature. So the first 20 elements on the periodic table are fundamental to understanding the basic chemistry. Yes, in fact, you know, at secondary school level, more especially the junior section, we focus much on the first 20 elements. And these 20 elements, they are very, very important in the study of chemistry. Because if you talk of physical chemistry, environmental chemistry, analytical chemistry, all the branches of chemistry, they are based on this periodic table. So the periodic table is very, very crucial. It is very, very important. So the first 20 elements in the periodic table, they are arranged according to the atomic number and are placed in specific rows based on their electron configurations and their chemical properties. So we all know what a table is. You see, a table will have columns and rows. So even the periodic table, it has columns and rows as well. So the horizontal arrangement, which are periods, as you move from left to right across a period, each element has one more proton and electron than the previous element, filling up the same electron shell until it's complete. Then we have vertical arrangement groups. As you will see in the other slides, elements in the same group share similar properties and have the same number of electrons in their outermost shell. So this arrangement helps predict the chemical behavior of the elements and how they interact with one another. So what are these periods? So the periods, they are rows of the periodic table. And the first 20 elements are distributed across the first 4 periods of the table. So the first 20 elements, they are distributed across the first 4 periods of the periodic table. So how many periods do we have in the periodic table? Yes, there are 4. So let us go through each period. We have period 1, which contains 2 elements, namely hydrogen and helium. Hydrogen and helium. So why are they found in period 1? It is because they have only one energy level or shell. Remember on the importance of electron configuration? Yes, electron configuration will tell us the number of electrons and the number of shells. Then period number 2, period number 2 of 4, it contains 8 elements, namely lithium, then we have beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. So why are these elements found in period number 2? Simply because they have 2 energy levels. 2 energy levels. What is the other name of an energy level? A shell. Yes, it is a shell. Then we go to period 3, last but one, which contains 8 elements. And these elements are sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, and argon. So why period number 3? These elements have 3 energy levels. They have 3 energy levels. Then lastly, period number 4. And in period number 4, it begins with the first 2 elements, that is potassium and calcium. Potassium and calcium. So if you go to period number 1, we also have 2 elements. Do you remember them? Yes, helium and hydrogen. Similarly, in period number 4, we have 2 elements, potassium and calcium. Why are they found in period number 4? Because they have a maximum number of 4 energy levels, 4 shells. So what does it take for an element to be in a given period? For an element to be in a given period, I believe you have said the number of shells or energy levels. So all elements in energy, rather in period number 1, they all have 1 energy level. Period number 2, 2 energy levels. Period number 3, 3 energy levels. Period number 4, 4 energy levels. Let us proceed. What about groups? So these groups, they are columns of the periodic table. The vertical columns in the periodic table are called groups, and elements in the same group have similar chemical properties due to having the same number of valence or outermost electrons. Okay, let us go to group number 1. So group number 1, popularly it is known as the alkali metals. And these are the members, the elements, hydrogen, lithium, sodium, and potassium. So these elements, they are found in group number 1 simply because they have 1 valence electron. They have 1 electron in their outermost shell. And a brief description, they are highly reactive, especially with water. So this will be much, it will be discussed much in Form 2 on the chemical properties. Okay, let us proceed. Group number 2, alkaline earth metals. And the members include beryllium, magnesium, and calcium. And these elements have 2 valence electrons and are also quite reactive, though less so than group number 1. And this will be emphasized again in from 2 lessons. Then furthermore, group number 3, boron, aluminium. These are the elements in group 3. And again, these elements, they are found in group 3 because they have 3 valence electrons. They have 3 valence electrons. Group 4, we have carbon, silicon. The 2 elements that are found in group 4 because they have 4 valence electrons. Group number 5, members are nitrogen and phosphorus. So these elements have 5 valence electrons, 5 outermost electrons. Then group 6, members are oxygen and sulfur. Again, they are found in group 6 because they have 6 outermost electrons, 6 valence electrons. Group number 7 and group 7 members, they are commonly known as halogens. And the members are fluorine and chlorine. Remember, we are looking at the first 20 elements. It doesn't mean that we only have 20 elements. No. No. So, out of the 20 elements, elements which belong to group 7, there are only 2, fluorine and chlorine. Why in group 2? Because rather group 7, because they have 7 valence electrons and they are very reactive, particularly with alkali metals to form salts. Then lastly, the last group, which is group 8, the noble gases. Noble gases. The members include helium, neon, and argon. And these elements, they're found in group number 8 because their valence electrons, they have a maximum number of 8, with one exception, which is helium, because helium, it has 2 electrons. So we can give another reason for elements found in group number 8. So these elements, they have full outer electron shells. That is why helium is a member of group number 8, because it has one shell, and in one shell, for it to be full, it is supposed to accommodate 2 electrons. So you can see that for helium, the outermost shell is full, while the rest, the outermost shell is full with 8 electrons, meaning to say they have more than one shell. And they are inert, they are unreactive. No wonder they're called noble gases, meaning they are not reactive under normal conditions. So, what does it take for a given element to be in a given group? For the periods, we said the number of shells. What about for a group? What does it take for an element to be in a given group? Well, the outermost electrons, the valence electrons. However, group number 8, we are considering that which element has a fully filled outermost shell. Please take note of that. So the first 20 elements of the periodic table, they are as follows. We have helium. Rather, let us start with hydrogen. We have hydrogen, which the symbol of hydrogen is capital letter H. We have helium, symbol He, lithium, Li, beryllium, Be, boron, B, carbon, C, nitrogen, N, oxygen, O, fluorine, F, neon, Ne, sodium, Na, magnesium, Mg, aluminium, Al, silicon, Si, phosphorus, P, S, that is for sulfur, chlorine, Cl, argon, Ar, potassium, K, and calcium, Ca. Well, now we have our periodic table of the first 20 elements. So those elements, the 20 elements have now been arranged in the periodic table. Remember, this periodic table is for the first 20 elements. So as you can see, this is group number 1, this is group number 2, this is group number 3, this is group number 4, this is group number 5, this is group number 6, group number 7, then group number 8. What about periods? Period number 1, then we have period number 2, then we have period number 3, then we have period number 4. So as you can see, in period number 1, we have 2 elements. Can you name them, please? Yes, hydrogen and helium. How many elements do we have in period number 2? Yes, there are 8. Period number 3, 8 again. Period number 4, 2. Can you name them? Potassium and calcium. Good. Okay. Now that we have looked at the brief history or background of the periodic table, we have seen how elements are arranged in a periodic table, that is in groups and in periods. Let us go through the following activity. Please feel free to provide your answers in the comment section. And look for more questions on this lesson. Compare your answers for this activity with my answers, which will be provided. Okay, question number 1. What is the atomic number of carbon? Which element has the symbol Ne? What is the symbol for sodium? Which element is placed in group 1 and period 3? Which element has the atomic number 20? And name the element with the symbol O. Well, for any questions, you can contact the following number on WhatsApp. And you can also find information on help at xulendo.org. You can also visit Xulendo online and is xulendo.org. Well, for this lesson, I've used the following references. You can also go through them. Excel and Succeed Junior Chemistry Book 1, Achievers Chemistry Book 1, Django Chemistry Book 1, Samuel Kalea Chemistry Book 1. And for the other illustrations and designs and graphics, you have the following information. And all the photos, you can check the links for the photos. Until we meet for the next lesson, have a blessed time. Bye-bye.